All right. Well, I forgot to record this session during the lecture, so I'm just gonna repeat the topic that was covered then here to record it. So first of all, if you've already downloaded the content with a title, sequence types and loops, so try to download it again because I just updated it by adding this list comprehension topic. Okay. Um, so in the previous session, we talked about loops, so the while loop and the for loop. And in the while loop, we talked about the extra syntax that might not be familiar to you, like else here. Also, we tried the break, but we didn't try the continue. So let's go to the application that we had, or the exercise that we had here. So this is what we had at the end of the session last time. Now we have the break, and we know break just breaks out of the loop altogether. Now we can try this to exercise the debugging features. So if I run this in debug mode, let's say I wanna examine what happens inside the loop step by step, so that I can understand how the break works. So I can just run it in debug mode. So I put a breakpoint at the beginning of the loop here at line 4. So I should expect it. So you see it paused at this line. Now I can execute the code. I can see here there are variables. So the variables right now is only I. Now I can use the watch part to put the expressions that I want to monitor as I go. So for example, I'm interested to see this expression so that I can make expectation whether we should be entering the loop or not. So I can put this expression here in the watch. Yeah, so it is true right now. So we should expect the next step to go inside the loop. So line 6 here. So if I step, yeah, this is what I expect. So this is going all right. Now, this is another expression I'm interested in because I'm comparing my expectation to how the program actually works. Okay, so I equal 5 is an expression that I'm interested in while I am examining the execution. So I put it here in the watch. Now it's false, so I should expect that the program is not gonna step inside the block inside the if statement. So this line is going to be skipped. So line 8 will not be executed. Okay, so if I step, now it jumped to line 9. Okay, so now when I am examining code and I put a breakpoint and the code doesn't stop at this breakpoint, I know it was not executed. So I know there's a condition surrounding it, or somehow it was not executed. Okay, so I need to figure out why was it not executed, and I need to change the location of the breakpoint and so on. So now we are in line 9, so we should expect it to print one, like it started at 1, now it prints 2, and then again. All right, so now it's 3. So I is equal 3 right now. So this was false, and it's gonna print, and then same thing so this is gonna add 1 to this value. So I should expect this value to change. All right, so it did change here. Again, next iteration. Now when I plus equal 1 is executed, now I is equal to 5, and also we notice that the value of this expression changed to true. So now I should expect it to step inside the if statement and execute line 8. So when we go there, now we know a break will go outside the loop altogether. So it will step directly to the rest of the program. Okay, so this else was not executed because this condition was not false when the loop ended. Okay, so now we continue the rest of the program. All right, now what if we wanna instead of a break, we want a continue. So the continue keyword skips what is left from the loop. So execute the statements before the continue and skips the steps after the continue and move on to the next iteration in the loop. Okay, now let's say we now have understood this part of the loop. We don't want to examine it. We just want to go directly to when this statement is about to be executed. Okay, so I can put a breakpoint there to skip all the points, all these steps right before we enter the if statement here. So I'm gonna run it again. Now it should stop only when I equal to 5. Yeah, so all the previous statements were executed normally. Now I can see, so the I plus 1 plus equal 1 was executed. So the part that before the continue was executed. Now when we issue the continue, we are gonna skip all what is remaining in the loop and move on to the next iteration. Okay, so we see the 5 was not printed here. And then if we go next step, now it's gonna be 6, it's not equal 5. It's not gonna execute. You see, it didn't hit this line. And then we keep going. Now you see, I want to see whether it is going to, or maybe you just take it step by step. We're almost there. Okay, 8, 9. And then now it's going to be 10. We are going to print 10. And then you see, this is the last printing here because now I is equal to 11 and that changed that expression to false. And we should print it, but we should not enter the next iteration. Okay, so now once this expression is false, we skip into go to the else clause and then print that this loop was exited normally. Now we see here we may have discovered the bug. If the intention was to print only 1 to 10, then we didn't print 1 and we printed 11. Okay, so this careful examination can allow us to see problems with the code. All right. Okay, so now let's see the for loop. Okay, now the second type of loops here is the for loop, but it's not exactly the for loop that you are familiar with in Java. It more resembles the for loop in MATLAB, okay, or the for each statement that is in Java. Okay, so it iterates over any iterable. So the sequence types that we've been talking about are iterables. There are other types that can be iterated over, but at least the sequence types that we learned about, like the lists, the ranges, the tuples, and the strings, can be iterated over. Okay, now you see, let's go here. I have a list here. So I have a list of students here. And let's say I want to iterate over this list. So now let me comment out this part of the code. Now in Python, there is no multi-line comment. So this hash would comment only one line. But if I want to comment out a set of lines, I can put them in a triple quote string. Right? It's not really a comment, but it's not gonna try to evaluate the statements inside. All right, so let's say we have a list of students here. Let's say I want to print every element in this list. Now we can use the while. We can use the while loop, but as usual, we need to be careful. We need initialization, and we're gonna need somehow a stopping criteria. And we're gonna need an update that goes towards stopping. Okay, so now if we are going to use a while loop, we can iterate over a list using the index to access the elements one by one. So let's say we have a variable index that starts at 0. All right, so that's the initialization. Now we want to stop, we want to loop over the elements in the list. So our stopping criteria has to be something related to the length, right? So once we match, once the index equals the length, then we need to exit, right? So the way the while loop is that we put the opposite of that stopping condition, right? Because the while executes as long as a condition is true. So we put the opposite of that. So we say as long as while index is less than the length of the students, so our list. Now what do we need to do? We need to print. Oh, let me just put the element in, let's say, in a variable called s. Okay, and that is the students at index, at the value of index. All right, and then we'll print s. So now if I print it, right, now you see it keeps going forever. And why would that be the case? It's because I forgot to put the update, which is a common problem when we create loops like this. We forget to update, and sometimes the update doesn't really go towards stopping. So if I'm gonna add the update, I will need to have index plus equal 1. Now if I try to say minus equal 1, it's not, the loop's not gonna stop because the update doesn't go towards stopping, right? So that is a common problem. Uh, the update either not accurate or forgotten altogether, or another common problem with the loop. Now see here, because I fixed it, it now prints the elements in the list and then stops. Okay, try again. All right, so I did fix the problem, but it is a common mistake, common issue. Now, luckily, we don't have to worry about these details so much, because when we want to loop over elements in a sequence, we can just use the for loop, because it takes away a lot of the effort. So it takes away the initialization, it takes away the condition, the stopping criteria, because oftentimes, usually people miss the length, either exceeded or go below it. So sometimes if I say equal or equal, so this is gonna go out of range. And if I want to say equal, I have to add the -1. So oftentimes people forget the -1 and leave the equal there. So there is a more convenient way to loop over a sequence or a collection using the for loop. Okay, so I would just say for s in students, the name of the collection, and I don't have, so that will take care of the initialization and the stopping condition and the update. So all what I need to focus on is just what is it that I want to do with every element. So I just want to print it. So this is the only thing I need to worry about when using the for loop. All right. Okay, so that is the initial part of the for